Now we're going to look at the single bonded functional group called the alcohols. Now alcohols are organic compounds that contain the hydroxyl um, functional group somewhere within this organic compound, right? So pretty much you're looking at some kind of hydrocarbon, a long chain of hydrocarbons that will have this OH, or what we can call them also a hydroxyl group, right? You can have one, you can have two, you can have three, you can have several. Now, depending on the position, right? Alcohols can be looked at with regards to their positioning. So you can have alcohols that are considered primary alcohols, right? So primary alcohols, pretty much we're looking at some kind of a functional group, right? Some kind of alkyl group, and the OH is found at either end. It's just found pretty much on the very first carbon, right? So, and then we have a secondary alcohols in which we might have pretty much our carbon chain. However, the hydroxyl group is typically found on a carbon, right? On a carbon that actually has two other carbons around it. So the hydroxyl group is bonded to a carbon that is bonded to a carbon that has two other carbons to the outside of it. And the third type are the alcohol are called the tertiary alcohols, in which the carbon in which the hydroxyl group is attached to is bonded to three of them. So here we have our hydroxyl group. It's bonded to a carbon that is bonded to three different carbons all around it, and this is referred to as the tertiary. So let's think of it this way, right? Let's look at it this way here. This, and ignore the highlighting, the yellow here. So the hydroxyl group, which let me put in pink here, right? The hydroxyl group here is bonded to a carbon only. This hydroxyl group is bonded to a carbon that has two carbons bonded to it. And then this hydroxyl group is bonded to a carbon that has three different carbons bonded to it. So in this video, we're going to actually look at how to go about naming, how to go about drawing, and we're going to look at a few physical properties of alcohols. So let's go about naming it. Find where I have the example here. So here we have an example of an alcohol group, right? And so if we look at this this hydroxyl group is found on a carbon, obviously, but this carbon is bonded to two carbons, so we can say that this is a secondary alcohol. But now let's go about naming this. Now, naming this is very similar to any type of nomenclature. We are always going to want to find the longest hydrocarbon chain. So that hydrocarbon chain I'm going to outline in yellow is as follows. So let's find out how many carbons that long chain is. This chain is going to look like this. There's the longest carbon chain. So we're going to look at, we've got 1 carbon, 2, 3, 4, 5, 6 carbons. However, which side are we going to number this from? And when you're numbering, if you've got the functional group alcohol, right, we're going to outline that in pink here, we want this to have the lowest possible number. So we're going to number these carbons from here. So this is carbon number 1, this is carbon number 2, this is number 3, number 4, number 5, number 6. So we've got 6 carbons in our chain. And so we know this, and they're all single bonds, so it's known as really a hexane group. But the rule for naming, right, the rule for naming when we have this alcohol functional group is to drop the E and add in OL. So hexane, which is the derivative here, is not a hexane, but the main chain is a hexanol. Now the key is, though, where is this OL? Where is this alcohol group located? It's located on the second carbon. So we're going to name this as a 2-hexanol. But that's just the main chain and this functional group. What we also need to make note of is this functional group. This is a 1-carbon branch, right? So this branch is a methyl, right? So where is this methyl located? It's located on the number 4 carbon. So it is a 4-methyl. And now what we're going to do is we're going to put this whole name together, and we're going to name this a 4-methyl. And we're going to bring this part in. But we don't just write the 2, right? Remember, we use dashes to separate numbers and letters, right? And when we're separating numbers from other numbers, right, if there's more than one branch, let's say, we'll use commas. But here we're only going to use dashes because we're always separating a number with a letter or a letter with a number. And the name of this compound is a 4-methyl-2-hexanol. Right? So the OL, meaning that there is a hydroxyl group, an OH, where? On the number 2 carbon. The main chain being a hexane, being the longest chain, and we have a branch that is 1 carbon in length on the number 4 carbon of our main chain. Let's look at one more example, and then we're going to look at drawing these things. So let's look at the following example here. Take a moment and actually try using the rules that I showed you guys in a second ago to name this compound. So what we're going to do is we're going to try to find the longest possible chain, and the longest possible chain is this right here. And I could have branched it down here if I wanted to. Now, notice where the OH is. The OH is on 1 carbon, and that carbon is bonded to only 1 more carbon. So this is considered a primary alcohol, right? As opposed to the secondary alcohol that this was, right? This was a secondary, because as we said, where the OH was. Now let's go back to this example. So how long is our main chain? And so our main chain is 1, 2, 3, 4 carbons, right? And so to remember that, we remember the monkeys eat peeled bananas, right? So bananas for butane. So this is a butane. However, because of this OH, we're going to drop the E of the word butane and add in the letters OL. So we now have the main chain being referred to as a butanol. But the key is, where is that OL, or where is that OH located? It's located on, now we have to number these carbons. So we have the option of numbering it from the left or numbering it from the right. And if you said numbering it from the left, you're correct, because we want to make sure that this OH is on the lowest possible numbered carbon, and that carbon being number 1. So we've got carbon number 1, carbon number 2, number 3, and carbon number 4. So it's located on the or we could say the main chain is a 1-butanol. However, we also have one more branch here, right? This branch, 1 carbon in length, so it is a methyl group. And where is it located? It's located on the 3rd carbon, so it's a 3-methyl. How do we put this all together? This name for this compound is a 3-methyl dash 1 dash butanol. Now let's look at actually drawing some of these. So we're going to draw a 3-pentanol. So when drawing this, and now you can take a moment, you can pause this and actually try it yourself and see if you're going to get the same thing. But what we're going to do is we're going to draw this. So it's a 3-pentanol. So what we're going to do is we're going to identify a few things. The OL, meaning we've got an OH group. The pentane here, right, means that we have pretty much a 5-carbon chain, right? And this 3 is going to tell us where that alcohol is located. So let's draw our carbon. So what we're going to do is we're going to start with the 5 carbons. So let's start with the 5 carbons. 1, 2, 3, 4, 5 carbons. So we've got our 5 carbons, right? We've got an alcohol group, so we've got this OH. Where is it located? It's on the number 3 carbon. I always like to number it the way in English we read. So I like to number it like from left to right. 1, 2, 3, 4, 5. This is how we're going to number it. And what I'm going to do is I'm going to get rid of the numbering, just for argument's sake. And so we already know which carbon we're numbering it. So this is the number 3 carbon, and what we're going to do is we're going to put in our OH, and I'm going to put it here at the bottom. It doesn't really matter. I'm going to put my OH here at the bottom, and now what I'm going to do is I'm going to put in my H's. Now with this carbon single bond, so we can fit 3 H's here. I've got 2 bonds around this carbon, so I can only fit 2 of them. This carbon here, I've got 3 bonds to it, so I've only got room for 1 hydrogen. This next carbon, the number 4 carbon, has 2 bonds to it, so I have room for 2 more hydrogens. And this last carbon here has 3 hydrogens. So now let's look at what kind of alcohol we've got. Right? So right now we've got the OH on a carbon that has 2 carbons around it. So this is referred to as a secondary alcohol. So pretty much you get the gist of it. We're going to draw one more, right? And again, take a moment once you see the example and try drawing it yourself. So we're going to draw this. Now let's break down a few things here. So we know we've got a hexane as our main chain, so we know that our main chain is going to be 6 carbons in length. We know we've got an OH group located on the 3rd carbon, but we also have 2 other different types of branches. All right, so let's start off with our main chain, as we always start drawing our main chain. So our main chain is going to be 6 carbons in length. So 1, 2, 3, 4, and the way I'm counting them is how I'm going to number them. 5 and carbon number 6. All right. So we know we've got our alcohol group on our 3rd carbon, so we're going to find our 3rd carbon. Right. This is carbon 1, 2, and number 3. That's where we're going to put our OH. Then we're going to put in our methyl group. Our methyl is a 2 carbon. So here we're going to put in, or sorry, it was a 1 carbon, our methyl group, sorry. 1 carbon. And our ethyl is a 2 carbon, and it's on the number 4. So on the number 4 carbon, I'm going to draw 1, 2 carbon. So here is my monkeys eat, right, for ethane, right, or ethyl. And now all I'm going to do is put in all my H's. So we've got 3 H's here. We can only fit 1 there. We can only fit 1 there. We can fit 1 more H there. We can fit 2 H's there. And it's at the end, 3 H's. Now let's go to our branches. So this one branch, only 1 bond to that carbon. So it has room for 3 hydrogens. This carbon has 2 bonds around it, so it has room for 2 hydrogens. And this last carbon has room for 3 hydrogens. So let me outline this again. So here's our main chain. It's a hexane, right? It's originally a hexane, but because of this, it's a hexanol. Where is it located? On the number 3 carbon. And then we've got our methyl group on the number 2 carbon, and we've got our ethyl group here on the number 4 carbon. So hopefully you understand how to name it, how to draw them, right? So find a few examples either online or in your textbooks. What I'm going to do right now is actually I want to go through just a few physical properties about alcohols. So let's look at a few physical properties of alcohol. So one of them pretty much hydrogen bonding, right? So the hydrogen bonding, it has the ability to do that, right? It has the ability to bond with hydrogens. Why? Because it actually has the OH, right? That OH is considered polar, right? It can bond, it can form hydrogen bonds with other alcohols, or even forming a hydrogen bond with water. A second property pretty much is the melting point, right? We're going to look at melting and boiling points, right, of these compounds. Now, alcohols usually have high, right? They usually have a pretty high boiling point. So let's put it melting point and boiling point, right? Then pretty much than the alkenes, right? So they're going to have higher boiling point, melting point than the alkene that is the same length in carbons, right? Now, so now most carbons pretty much they're really liquids at room temperature, right? Keep in mind that a few other properties that we might want to add within the melting point is the fact that they're considered extremely flammable, right? And some can actually be poisonous, right? Some can actually be poisonous, right? We know ethanol, right? People like to indulge on the weekends with their meals, right? So sometimes they might be high consumption, right? It's St. Patrick's Day weekend, so we know a lot of people are going to be consuming a lot of ethanol this weekend. Something like methanol, right? Methanol, which is a single carbon chain, can actually cause blindness or even death if they're actually consumed. A few things. Also, another property we might want to look at is the solubility that alcohols have with water, right? And they're pretty much considered extremely soluble, right? They're extremely soluble. In fact, the smaller, right, the smaller the alcohol, right, something like a methanol or even an ethanol, they're really referred to as being miscible, right, in water. Right? So we don't really know which one is a solute and solvent. They just mix evenly together. Now, the solubility, however, right? Solubility, as we said, the smaller the alcohol, the more soluble it is. Solubility will actually decrease pretty much as the carbon chain increases. So the longer the carbon chain is of the alcohol, the less soluble it actually is. And the last thing to make note of is regarding its polarity. All right, we know that the OH is a very polar, right? Now the thing is, though, small alcohols are more polar, right? So pretty much small alcohols have a greater polarity with regards to larger um, or larger chain really hydrocarbon chain alcohols. All right. So if we're looking at, sorry for the writing, like we can have a huge chain of carbons, right? And then this one little bond, right? Look at all this of hydrocarbons, right? That will be considered, right? That is considered non-polar.